Welcome to the program. Okay, so we left off last time talking about triangles, right? So if we have a right triangle with angle theta, all right, and remember that theta is just the angle that we specify. It could be either angle that's not the 90-degree angle. So if we call this bottom left corner theta, the side that's opposite will be this side. So this is opposite. And then the side that is touching theta is called the adjacent. And the side that's opposite the 90-degree angle is called the hypotenuse. Right? And so we came up with the trig functions, sine, cosine, and theta, and their inverse functions. And so those real quick were sine of theta is equal to opposite over hypotenuse, and then cosine of theta is equal to adjacent over hypotenuse, and then tangent of theta is equal to opposite over adjacent. And the other three were the inverses of these. So we have cosecant, abbreviated CSC, of theta is equal to the inverse of the sine. So that will be hypotenuse over opposite. And then we have secant theta equal to the inverse of cosine. So that's hypotenuse over adjacent. And then we have the cotangent, abbreviated COT, of theta is equal to adjacent over hypotenuse. And so the only other thing we learned yesterday is that when we use these trig functions, if we come up with a fraction with a radical in the denominator, we clear it. Okay, so we're going to use these trig functions today to come up with solutions to unknowns, because that's what we do in algebra. So the first example 1, we'll say where we'd be given a triangle. Okay, let's say this is our triangle, and we're given length 5 is given and length 12 is given. So, and we're going to specify the angle theta up here. So the first thing we're going to ask, and this is a review, is for the hypotenuse. Equal to what? Well, hypotenuse is given by Pythagorean theorem, which states that a squared is equal to a squared, let's undo that, a squared plus b squared is equal to c squared. So in this equation, you have to know where the hypotenuse is. The hypotenuse is always opposite the right angle. So this side right here, the length of that distance is our hypotenuse, h, or in this case, c. All right. So we set up the other legs. A and B are considered the legs. So we set it up as 5 squared plus 12 squared is equal to c squared. All right. From there we have 25 plus 144 is equal to c squared, and c squared is equal to 169. C is equal to 13. Okay, That means that this distance is no longer unknown. It is known as 13. That's supposed to be 13. Okay, so now we have 13. And so now that we have this side known, all right, we want to say evaluate all 6 trig functions. Okay, so what are the 6 trig functions? Well, that's here, all right? That should be in your notes. And we're going to use these sides, the sides 5, 12, and 13, to come up with our 6 trig functions. So sine of theta is equal to, we're going to do, so here's theta, right? And that's equal to the opposite over adjacent, right? So in this case, opposite over hypotenuse. And so now we have sine of theta is equal to 12 over 13. All right? For cosine theta, that's adjacent, the side that is touching theta, that is not the hypotenuse, adjacent over hypotenuse, 5 over 13. And then for tangent of theta, that's O over A. So there it is here, adjacent O over A. And this is where we're looking right now. What we'll do is look at the picture and opposite over adjacent. So we have 12 over 5. There are no radicals in the things we come up with for our sine, cosine, and tangent. So the other 3 inverse functions are just these fractions, the reciprocals of these fractions. So now we have cosecant of theta is equal to the inverse of the sine. So this is going to be 13 over 12. Secant of theta is equal to 13 over 5. And then cotangent, abbreviated COT, of theta is equal to 5 over 12. All right? So that's the first example. Now, we can get trickier with this, example 2, by saying, just want to check my time here. Okay, so I'll write it out, right? So if theta is an acute angle of a right triangle, and sine of theta is equal to 4/7. What is the tangent of theta? This looks like a park question. What is the tangent of theta? Let's draw a diagram, right? Always helps to draw a diagram. So we'll get a triangle going. These are right triangles, right? And we're going to just call this theta down here. And they said sine of theta, I'm just writing the given information again, is 4/7. Well, we know sine of theta is equal to opposite over hypotenuse. So I'm just going to look at theta, and I'm going to look opposite, the side opposite. That makes this side what distance? You should know this. Opposite of theta would be 4. And then hypotenuse is the angle that the right angle is opposite. Right angle is given by the little square in the triangle. Opposite that side is this distance here. So this distance now is given as what? 7, right? Now, it says here, what is a tangent of theta? Well, tangent of theta is equal to opposite over adjacent. So if this is theta at the bottom left, and we know the opposite side is 7, we don't know what this side is. That's the adjacent side. And we need that adjacent side to get our our fraction going for tangent of theta. So we need to use the equation that relates the sides of the triangle, the right triangle, and that is the Pythagorean theorem, which states that a squared plus b squared equals c squared, right? And so we say x squared, the unknown side, plus the known side, which is 4, is equal to 7 squared. So this is going to be x squared plus 16 is equal to 49. And we have x squared equal to, subtract from both sides 16, and I get 33. And now I have x is equal to root 33. All right? So the tangent of theta, all right, we could set it up now. But does anybody see there's going to be a problem with that? Let's see. So tangent of theta is equal to the opposite side, which is 4, over the adjacent side, which is root 33. But there is a radical in the denominator, so I'm going to multiply by 1. 33 divided by 33 is equal to 1. So now I have 4 root 33 over 33. And that is the answer to the question. You got to remember what the question was, tangent of theta. So we had to do all those steps to get to the tangent of theta. All right? And so we'll stop it there. Thank you for watching, and hopefully this helps.